Yeah, okay. So other classes will be watching this now. Can you like do that later? Can you turn to, it's like some problem about like Tallchief or whatever.
Page 17.
Yeah, page 17, Mr. Tallchief. By the way, I got this from a textbook, and I like didn't change any of the names because I just thought, whatever, I'll just like type it up exactly as is. And in the textbook, they were like Mr. Tallchief, and I think there was like some like kind of awkward 80s attempt at like being racially inclusive, so they just did like a little bit of everybody, and then there was like, you know, one Asian word problem and there was one Native American word problem, and they just like kind of, that was just a thing. I didn't really thought nothing of it. This one kid in my class like flipped out on me. She was like 1/16 Native American, and she was like, "This is racist."
Scott?
Scott, are you 1/16 Native American? All right. You are also? Alright, so interesting things to know. But anyway, this girl, she just got so mad at me. She was like, that's right. I'm like, how's it racist? Like, I don't know, it was like this whole weird showdown class. So every time I do this problem, I think of her. I was like, I don't think it's racist, this is just his name. Anyway, she's like, you think everyone's name is something silly, like dances with, you know, whatever? And I was like, listen, I don't know, I just got it from a textbook. Anyway, alright, so Mr. Tallchief, reaches his retirement age of 6. Oh yeah, everyone should read the problem real quick. Yeah, should read the problem. What?
Sorry, that was, it's just funny because it's recording.
I know, well yeah. Might as well make it a little exciting.
Joe, tell me the word for word, especially like the typo in the third one.
Oh yeah, there's a typo, I spelled a word wrong. Just relax. Okay. Would someone like to explain in just simple language what is going on in this problem? Griffin.
So we put $400,000 in a 9% interest rate thing. So he's getting 9% every year, but every year he takes out $4,000 from it. So we're just trying to figure out how long it takes until he runs out of money.
Classic Griffin casual read through the problem with crucial errors in all the
Oh,
places.
it's a month.
Yes. How much did he take out?
$4,000 a month.
$4,000 a month. Yes. Good. Yeah. So this guy retires. Like a very responsible citizen, he has saved a bunch of money. $400,000. That is enough to live on in 1985, especially. Usually people just were dead by like 73 back then or whatever. What is he going to do? He is going to take out $4,000. He's going to live off of $4,000 per month. The question is, is he going to make it basically? Well, all right. Let's suppose he were keeping the money in his in a box under his bed, not in a bank account. Just by doing some quick calculations. How many months does he have until he runs out of money? 100 months, right? So that's about like how many years? Like 7.5 or so.
Yep.
Okay, so not so bad. But you're just kind of thinking or just talking this out now. If he keeps the money in the bank, he should make it longer, right? Because while he is still withdrawing the money that he hasn't withdrawn yet is sitting in there like earning some interest, right? And 9%, I mean, that's pretty good. So we should expect him to be able to make it longer than that. All right. So we need to do this problem, and we need to do this problem very. All right. So someone else, just point out some key features of this problem. Just like thinking. Yes, Liam.
9% is compounded monthly.
9% compounded monthly. Right.
Is it compounded before or after he takes it?
Okay. Yeah. Before we even get to that, so what's nice about this problem? What's nice about this problem? Everything is like per month. Okay. So Rod Fleischman says it's compounding monthly, but it's also the case that he's taking out the money monthly. Okay, so I kind of talked about this last class, right? The compound interest formula, per se, is going to be just like totally useless to us. Because the entire point of the compound interest formula is like you put the money in the account and then you don't touch it, and then just like lots of time goes on, right? But in this problem, we're messing with his account basically every month, right? So if we can imagine what's happening, it's like he has his money in the bank account, and then each month it earns a bunch of money. And then he goes in at the end of the month, he takes out some money, and then just after he takes out the money, or I guess, yeah, whatever, simultaneously or something like that. He takes out the money and then they take that amount and that becomes the principal then for the next month. Is that one kind of just like, before we actually start the math? Okay, good. Alright, so let's try to do it. I kind of already like told you what to do here, which is like sort of lame of me. But I already said, alright, let's pick some variables. Let's pick the variables that A sub n is the amount of money in the account n months after his retirement. So this is amount of money in account n months after retirement. I guess I said end. Like you could theoretically do it either way, but I said at the end, right? After retirement. N months after retirement. Okay, yes.
Is the interest amount?
Yeah, hold on, we're going to get to that in a minute when we get to it. So what's the, so let's tell me something that I know then. Once I've defined this variable precisely, just like give me a fact.
A1.
Is it A0 or A1?
Zero.
I guess it's A0, yeah, not this. Yes, it is definitely A0. Because 0 months after his retirement, he has 400,000. Okay, yeah, he doesn't take out, this is getting confusing. 1 month after he retires, and every month thereafter. He intends to withdraw. Okay, yeah, so he doesn't take out, so at the beginning he has 400,000. This could be worded slightly better, I'm seeing now. At the beginning he has 400,000, but I think he doesn't take out his first withdrawal until a month has gone by, right? That's kind of what it says.
Yeah.
So
Yeah.
the compound, they take that, or do they take it out?
Yeah.
Okay, so yeah, so now the money has been sitting in his bank. So everything works. It works in the way that it makes sense. It would work like being fair. So if he has no money in he has this much money in the account, and then how much money is he going to have? So the first time he goes to the bank to make the withdrawal is after a month has gone by, right? And at that point. He's earned some interest on that money. Just imagine that it happens simultaneously. Imagine that he doesn't actually go to the bank, but the account just like sends him some money to puts it on some debit card or something, and then also compounds. Does that make it kind of make sense better?
Yeah.
Which happens first?
Yeah, that's okay. So what do you like they happen at the exact same time. He he withdraws the money, and then that amount of money, then the money that's left becomes the new principal for the following month.
So he withdraws it first.
I guess he withdraws it first. Yes, if you'd like to think about that one. Okay, so but before we even get to how much he withdraws, let's talk about how much some interest was earned this month. Okay, this is the key important step. How much? And maybe I'm just going to let you guys do this for a minute right now. How much money did he make that first month? Go, compute that. Thinking very carefully about this.
You got it.
Oh,
That's the annual interest. Compounded once.
You don't need a calculator because we're not. Let's assume you're doing this whole problem without a calculator using me. So I don't want a number. I want like a algebra expression or something.
0.09 divided by 12 times 1,000.
Wait,
Okay.
so he does it compound.
Just walking around, seeing what everyone's doing. You are wrong, and that's expected.
like an algebraic.
Before or after the withdrawal?
Did you just say it's
Like not
Yep.
Yes. You're just pushing ahead, but I think that's right.
I already did this like a while ago.
You did this a while ago.
Part of it a
So
while
that's
ago.
wrong, and that doesn't even make any sense. You just remember, this, I can tell, yeah, I think that's right. That's wrong.
Wait.
Right. You're like, don't have a packet for some reason. Trouble with signs. Yeah, I think that's right. This table kind of was working together-ish. Okay, what's the issue here? Guys, those of you who seem to be doing it right, what's the issue that we need to be aware of? Char, why were you wrong a minute ago? Yeah, so it's 9% is the annual interest. We always quote the interest as an annual interest rate. So the 9% means that you are making, in a year, you will earn 9% on whatever was in the bank, right? But this is just a month has gone by. It's definitely not 9%. 9% a month interest is crazy interest. That's like really good. So, how much money does he make over them? Well, maybe we could just do like a side calculation, right? If a sub 0 is my principal, then how do I compute how much interest I'm going to have over that month? Well, we really just use the simple interest formula, right? The simple interest formula says that the interest is just the principal times the rate times the time. And so if I had a sub 0 at the beginning, then 1 month later, I'm going to have a sub 0 plus a sub 0 times, this was the original amount of money, plus the amount of interest that I earned over that month. And how much interest did I earn that month? Arlo, can you make sure I'm in frame? I'm not positive that I am.
You're not.
Yeah. How much interest I made that month is a sub 0 times the interest rate, which is 0.09 times the time, but what's the time?
1/12.
Yeah, the time is 1/12. We have to do the time in years because the annual interest rate is quoted in years. Okay, so what we end up with is this formula. It's the amount of money I'm going to have in the bank is a sub 0 times 1 plus 0.09 over 12. Follow? Okay, so that is how much, that is what his bank account would look like 1 month later. 400,000 times 1 plus 0.09 over 12. But of course, the other thing that happens is
Takes out 4,000.
he takes out 4,000. 4,000. Right? So we have the money, which earned a certain amount of interest. How much? That much. And then he takes out, at the end of he makes his first withdrawal. The way the problem is written, he makes his first withdrawal at the end of the first month. Is everybody cool? Yeah. I think this is all good. Okay, good. So now this amount becomes his principal now, right? And so when we check back in on his bank account a month later, he is going to be earning interest on this amount. Well, therefore, how much interest will it be? Or how do I find how much is in the, how do I find what his new balance is? Yeah, Dee Shetty. Yeah, basically the exact same logic applies now, right? To figure out the interest earned, I just take a 1 times 1 plus 0.09 over 12. Because now A1 is the principal. Does everyone see how it's kind of like the exact same logic, Liam? You're cool? Okay, so A sub 2 is going to be just A sub 1 times this expression. So this is going to be now 400,000 times, I'm just going to write it as 12.09 over 12, since that's what it is. 12.9 over 12 squared minus 4,000 times 12.09 over 12. But then also, he takes out 4,000 again. Right? So there's initial amount of money, then there's initial amount of money times the interest earned on the first month, minus the first withdrawal, and then that amount becomes capitalized, or principalized or something, I'm not really sure. Anyway, and then you multiply it by 12.09 again. Okay, so now do you guys kind of see where this is going? Let's just do one more. How much is in the bank after 3 months? Well, after 3 months, we'll be earning interest on the amount that was in the bank at the end of 2 months. Times 12.09, so we get another like times 12.09 over 12. So each term gets multiplied by 12.09 over 12 each time, and then again the other thing that happens each time is we subtract 4,000. Who is with me? You kind of got to go nice and slow and careful. All right, so then. How much is in the account after n months?
A1 minus 1 times 12.09 over 12 to the n.
Calvin's mumbling for once, I can't hear him. What is it again, Calvin?
400,000 times 1 plus, or 12.09 over 12 to the n.
Correct. To the
Minus
n.
4,000 to the times 12.09 over 12 to the n minus 1 dot 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 till minus 4,000.
Yeah, can I just factor out the 4,000 all in one step?
Yeah.
Okay, so then the first term is, just like you said, it's 12.09 over 12 to the
N minus 1.
n minus 1. That's key, right? Just have to like see the pattern and like not mess up. And then we just have dot dot dot, and then we kind of end with,
Minus 4,000.
yeah, I factored out the negative, so now it's just
Plus
gonna,
1.
Yep, I'll just include one more term. Everybody good? Michael Clark, you good? Okay, good. Now just apply the sum of a geometric series formula to this. So this is going to be, what's going to be? What's it? Oh, from you, what's it going to be? It's going to be n, right? You got to be careful. Well, I guess we're, wait, what?
Okay, yeah.
Oh, which is it? No, I was saying that you're right. I was just repeating you to the class and you panicked. Yeah, it's to the n because there are n terms here, right? Because we start with like 0, we go to, but anyway, yeah, you gotta be careful with that. Over,
Negative 1 minus 12.
yeah, 1 minus 12.09 over 12. And now we can kind of like simplify this, I guess, because this is kind of like annoying. So yeah, so he says that this is like 12 minus 12.09, so it ends up being, can we just like flip the negative and do some simplifications like all at the same time? So this is actually like 12.09 over 12 to the n minus 1 over, can you peek in there and make sure it's visible? Over, what is that in the denominator? Now it's like 0.09 over 12, I guess, right?
Yes.
Yeah.
0.09 over 12. So I flipped the negative and did the subtraction at the same time. And I guess we could even simplify that more. What is 0.09 over 12?
It's like.
It's like 3 over 400, right?
Yeah.
Yeah.
Yeah, because I can divide by 3, and I also, yeah. So it's 3 over, so this is really just like the same thing as over 3 over 400. Okay, so now I probably need you to move the camera maybe, or pretty soon. I'm continuing to simplify, like doing it algebra style. A sub n is going to be 400,000, 12.09 over 12 to the n, minus, once I realize that that's 3 over 400 in the denominator, I can just like middle school flippy that up, and I get 16 and like 5 zeros, right? Who's with me? Everybody good? I won't even look up because that's how much confidence I have in you. The n minus 1. And now I basically just have this giant, I guess I could even like keep simplifying that if I wanted to.
400,000.
What's up?
Yeah, why?
400,000.
Yeah, I don't even think I want to factor it. I think I just want to like, because these are pretty much like terms, right? Are you with me?
Yeah.
Isn't that just like, this is like 12. So this is like 1.6 million over 3. This is like, would be 1.2 million over 3. So I think I end up with negative 400,000, is that right? Over 3. I'm just doing like fractions. Plus this. Someone check that. Is everyone cool? I just distributed the, is everyone cool?
Yeah.
Sammy cool? Okay.
Is this basically like when you did in the homework question?
Yeah, it's just like harder. It's just like a harder version of the same thing. Okay, that's about as simplified as I want it to be. Now it's time to answer the question. What's the question?
For how many months will there be no money left in the account?
Right, so pretty much figure out when is this 0. Okay, do that right now. What? Is this like yours? You seem to be getting a calculator like each month.
Take it if no one wants it.
Nope.
I tried.
So try to do it in a used calculator only at the last step kind of way, you know? That's like algebra. Yeah.
It's this right here. Did you get this? It's an actual.
Even that you can simplify. Like, isn't that like you had like 3 or something? No, really more. It's like, okay, take it back. I'll just leave it as is. So, do you guys get to this point where you basically just need to solve that equation, right? Junie, cool? Now use logs. URM. Almost. Yep. So let's take some kind of log on both sides, natural log or whatever it is.
10, 15. Pretty good.
Okay, so the final answer is that n is ln4 over ln 12.09 over 12. And doing that out on the board, we get 185.532 months. Is that what you guys got?
Yeah.
Okay, can you handle problems like this? Okay, good. Actually, how many can you do a little divide by 12?
That's like
Oh,
15 years.
15 and a half.
Yeah, so it's like 15-ish years. 15-ish years he's got. That's pretty good. Okay. Good. I will now close the video.